Hey crafters, this is Nilton from craftofprogramming.com. In this video, I'm going to be talking about the Reentrant locks, which is part of the Java standard library. Now, the Reentrant locks are less convenient and harder to use than the Java built-in locks provided by the synchronized keyword. So in this video, I'm going to show you why you would consider and you should consider using the Reentrant lock as opposed to built-in synchronized lock by way of examples where I'm going to be showing a bunch of benefits. Okay, make sure you stick around till the end in this video, because at the end I'm going to show you one of the biggest benefits of using Reentrant locks. Let's get started. As usual, let's create our main method, and basically the most basic lock, Reentrant lock you have is a Reentrant Lock class, which implements the lock interface. Okay, so that's the one we're going to be using for this example. So what I want to do is I want to create an instance method here, which I would like to call lock, if IntelliJ allows me here. And this method will basically take a boolean, which is, let's call interruptibly, right? And what I want to do here is give the caller the option to invoke a lock that honors the interrupt status of the thread, or doesn't, depending on this flag, right? So let me insert a Reentrant lock. So what I want to do here is I want to use the interruptibly parameter to decide on how I'm going to acquire this lock, right? And that's kind of what I want to do here. So basically this is what I want to do. Okay, and this guy here throws an interrupted exception, so just going to add to the method here. Now, what does this thing does, right? Lock interruptibly attempts to acquire the lock if and only if the thread status is not interrupted, right? If the thread has been interrupted when it tries to acquire, to call this method, and it will just throw an exception and abort, right? Whereas the standard lock invocation does not check the thread status, right? Another behavior here of this is when you invoke the method, right? If the thread is not being interrupted, but say the lock is held by another thread, while waiting for the lock to be released, if the thread is interrupted, it will still throw an exception. Okay, so that's kind of what I want to do here. And inside this method, I just want to call I don't know, execute, just something here, and then a method called sleep. Let's create these methods inside, let's say here, and I probably want this to be static. And here I just want to print some basic thing about the thread. Let's say is executing a guarded method. And for sleep, you know, let's just again make it static, and let's just have this thread sleep, I don't know, for say 1 second. Okay, and as usual, sleep has I need to, let's surround with a try catch block. Okay, so that's basic stuff we have. Now inside main here, let's create our thread. Oops, let's just try to format this. And basically what I want to do is I want to check while the thread is not interrupted, right? I want to basically wait, so let's just sleep. Okay, after the thread has been interrupted, then I want to invoke this lock with interruptibly parameter set to true. So obviously, because this is an instance method, let's create an instance of the ReadWrite of the main class here. Let's call it lock main, it's fine. So then I want to call lock main lock, and I want to pass this flag to true. Okay, and obviously this guy throws an exception, so let's run with a try catch. All right, okay, so exception throws an interrupt exception. So basically let's see what I'm doing here, right? Actually before that, let me just start and have main interrupt the thread. Okay, So what am I doing here, right? I'm creating a thread, right? And I want to make sure that when the thread calls this lock method with interrupter set to true, it has been interrupted. So while it's not interrupted, it's going to be sleeping and waiting, right? Then wakes up, checks interrupt status. If it is interrupted, then it calls lock with the parameter set to true. If it's not, it sleeps again, all right? So let's demonstrate. Let's execute this. So as you can see, the thread has invoked lock and called lock interruptibly, and because the thread had this interrupt status set to true, which is done by main, then it basically threw the interrupted exception, okay? Now, let me show you that if I had called this method with parameter false, right? Okay, remember, this is being called with the thread having its interrupt status set to true. If I call false, then the thread will just acquire the lock and then execute. Let's demonstrate. As you see, when I call just a lock method, not lock interruptibly, even though the thread had its interrupt status turned on or set, it will still, acquire the lock. It didn't throw an interrupt exception and executed the execute method, okay? And the reason why sleep interrupted is printed here is because, remember, the thread has its interrupt status set, and then when I call sleep here, right, then sleep itself will throw an exception. I've changed it a little bit just to print the message, okay? Okay, so another benefit of reentrant locks is conditional lock acquisition based on whether the lock is currently held or not by another thread. So again, let's create an instance method here, which we're gonna call try_lock. Let me implement this method simply. And this is basically using lock try lock, okay? So try_lock it returns true immediately if the lock is available for acquisition, okay? Else it returns false immediately, okay? So I want basically to create here two scenarios here. This would be our usual lock acquisition pattern here, where I'm going to call execute, and then I'm going to call sleep, and then here I'm going to unlock it. And else, what I want to do is I want to create a method called execute unguarded, because this is something that is executed without holding a lock. And why not? Let's just also sleep, and let's create this method static as usual, and let's just move this thing. So let's print here, and let's just say is executing unguarded method. Okay, so as usual, let's insert here our two threads, and T2 is going to also call try_lock, all right? And let's start both threads, and main as usual is going to join, okay? So basically what I'm doing here is the first thread will, or whichever thread is scheduled first, will acquire the lock, right? And then the second thread that gets scheduled will fail to acquire the lock because it's held by the first thread. Now, there is a bit of timing here, but if you look at the method calls sleep, and sleep is sleeping for 10 seconds. So there is a big chance that by the time the second thread is scheduled and calls try_lock, the lock will still be held by the first thread, okay? Let's execute the method. So as you see, the printing is a little bit printed in the reverse order, but T1 got scheduled first and it acquired the method, right? It hold the lock for 10 seconds. T2 then got scheduled. When it called try_lock, the lock was still held by T1, and it just basically did not attempt to acquire the lock, right? It just went to the else block and called unguarded. Now there is a variant here which I want to overload, which takes a parameter, let's just call timeout, which I can pass here. Okay, try_lock is an overloaded method that takes a parameter, and let's just say that my time unit will be seconds. Okay, this actually throws an interrupted exception. So what is the difference between try_lock with a timeout versus the try_lock without a timeout? Well, try lock without a timeout, if the lock is not held, it acquires it, but if lock is held, it just gives up immediately, right? Whereas try lock, you want to wait up to the timeout to see whether the lock is available, instead of just, giving up if the lock is held by another thread. Okay, so what I want to do here is, again, playing a little bit with timing. It's not guaranteed, but what I want to do is I want basically to increase the timeout, right, to be greater than the amount of time the first thread is holding the lock, so that this thread that it's doing this try lock with a timeout actually ends up acquiring the lock. Okay, so let's change the sleep to maybe just 2 seconds. So now here, obviously, I need to convert this because I want the second thread to call try lock, with a timeout. And let's say I'm willing to wait 10 seconds for the lock. Okay, and obviously this guy throws a interrupt exception, so it's wrapped here on interrupt exception. So let's see, try lock calls sleep for 2 seconds. So remember, what I'm trying to do here is trying to increase the chance that when T2 invokes try lock with a timeout of 10 seconds, T1 is still holding that lock. Okay, so I don't know, let's just sleep here for 500 milliseconds or alpha second. Okay, so let's execute this. So again, there are no guarantees, but that's pretty much what is happening here, right? So T1 execute the guarded method. We assume that T2 got scheduled, and when it invoked the try lock method with the 10 seconds timeout, the lock was being held by the first thread, which then terminated, released the lock, and this guy was able to proceed. So now towards the end, let's talk about one of the most useful features of Reentrant locks, which is using Reentrant read-write locks. Now this is super useful when you have a problem where you have many reader threads, right, compared to, say, one or few writer threads, right? The number of reader threads far exceeds the number of writer threads. When you have that type of scenario, it's very useful to use Reentrant read-write locks. Why? Because a Reentrant read-write lock allows multiple threads, reader threads, right, to concurrently execute the guarded method or block of code, which is guarded by the Reentrant read-write lock, right? Whereas the writer thread, right, which acquires a write lock, needs to execute that exclusively, obviously, because it mutates the state, right? So this feature of allowing multiple reader threads to execute the same code concurrently, simultaneously, can, like I said, greatly increase the throughput by allowing all those reader threads access to the lock instead of having to wait. To motivate this example, suppose you have an ice rink. There is an ice rink, the standardized rink where you skate, and the ice rink allows multiple ice skaters, right, to skate at the same time. So at any given time, multiple skaters are using the ice rink, they are skating. But then once in a while, right, all skaters need to be removed off of this ice rink to allow for resurfacing and cleaning of the ice rink. When the rink is being resurfacing, no skaters are allowed in, right? And the resurfacing needs to wait for all skaters to leave, right? So that's kind of the problem we're going to be doing. The resurfacing will be guarded by a write lock, meaning it has to wait for all the skaters to leave the rink, and while it is resurfacing, no skaters are allowed in, and the skaters will be guarded by a read lock, thereby allowing multiple skaters to use the rink at the same time. Obviously, while the skaters are using the rink, the resurfacer or cleaner needs to wait until all skaters leave the rink. All right, so let me insert a static inner class here. It's the Reentrant read-write lock that we want to use. Let's call the read-write lock here. I would want to use a read lock, and I will want to use a write lock. Now let me create here my constructor here. Okay, let's create this guy. All right. Then my read lock will be the read write lock. You call read lock on it, and the write lock is obtained by read write lock write lock. Okay. So this is the first thing you need to use, right? The way you acquire the read and the write lock is off of the same instance of the reentrant read write lock. Okay. It has this nice, factory method. Let's create our skate method, right? So skate method, okay? So as usual, let's use our pattern here to insert a reentrant lock. Like I said, this is going to be guarded by a read lock, right? So skaters use the read lock, thereby allowing multiple skaters to skate at the same time, okay, in our wonderful rink. So when they are skating, I just want to print something here that says blah 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 is skating, and at the end I want to say, after they're done, just say that is done skating. The resurface cleaner will use the, not surprisingly, the write lock. Okay, let's use write lock, and let's print the blah 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 is resurfacing, and then after it's done, it's gonna say is done resurfacing the ring. Okay, so that's basically the main gist of the thing. The cleaner or resurfacer we call resurface method, which is guarded by a write lock. Skaters are allowed multiple skaters at the same time. They're gonna be calling read lock. All right. Now there is one more thing that I want to do, which is, suppose a skater is trying to skate and a resurface is going on at the moment, right? I would like to see on the console, this condition, right? Okay, I can't skate. Why? Because there is a resurfacing going on. So let's do this. Remember, this is an application of the try lock that we used before. So I can do read lock, try lock, right? And remember, if a try lock returns false, then it means that the lock is being held by another thread. In particular here is being held by the writer thread, okay? In other words, the reader cannot acquire the lock. This can only happen if the lock is being held by the writer, which is done in mutual exclusivity. So here what I want to say is this guy can't skate, okay, because there is an ongoing resurfacing, okay, and as such we'll wait for it to finish. Okay, so notice that if the thread acquires the lock here, right, then it's going to attempt to acquire the lock again. It's a bit pointless. Let's move this inside the if block, because if it doesn't acquire the lock, then you want to acquire the lock inside the if block. All right, let's do something similar in the resurface, but obviously on the write lock. Then obviously we're going to be doing that on the write lock, and here it's actually the opposite, right? If the thread cannot acquire the write lock, it means that there is another writer holding the write lock, which in this case it doesn't apply. We're only going to have one cleaner or resurfacer, but in this case will be because there are skaters on the ring, so can't resurface because there are skaters on the ring for everybody or every skater to leave ring. Actually, before going to main, let's add here a sleep. So to make the example a bit more realistic, let's say that the actual resurfacing takes always the same time. Let's see how long we are using here. That's okay. We good with 2 seconds. But then skating, you never know how long it will take. Let's create another method here, sleep random. Let's just do that. And here, let's say we want to sleep, I don't know, up to 6 seconds, right? So let's go to main and let's have fun here. Okay, so first I want an instance of my ice rink. Okay, I have my ice rink. And now let me create my threads. So the first guy is going to be the cleaner, and the cleaner thread basically, while true, is just basically going to call ice rink, or rink actually, resurface. Okay, that's what's going to be doing. And let's say that in the beginning he's going to sleep for some time. Thread sleep for, I don't know, let's say it's going to sleep for 5 seconds. Okay, so this is for the cleaner, right? Now obviously we need a bunch of skaters, so because I'm going to create a bunch of skaters, let me just create here a method, like a factory method for a new, it's actually going to return a thread, a new skater, okay? And it's going to have a name, and I need an instance to the ice rink, right? And basically let me insert here my thread. I have my nice template here from IntelliJ. Basically what I want to do is I want it to sleep random, okay? And then I want it to call ring skate, all right? So it sleeps for a random time, then it decides to skate for a random time, and the cycle repeats, okay? So obviously the name is what gets passed here. I will let main start and join this, and let me just inline this. So here let me create my thread, so new skater. Let's use creative names here, John. Okay, ring. This is the John, and I'm gonna have a Paul. All right, so let's start John. Let's start Paul. So let's execute this. Okay, so the program has ran for a while. Let's just stop it and see what happened here. So John was skating for a while, and John was done skating, and then Paul was skating. Notice that Paul, George, and John were all skating at the same time. That's the whole point of the reader lock, allows multiple threads in. So all the skaters were happy, and notice what happened. It's just very interesting. So the cleaner was trying to clean the ring, but he couldn't. Why? Because notice that John, Ringo was skating. At least Ringo was there skating. And Paul, I think Paul was also skating, right? Because they were done skating here. So this cleaner had to wait, right? Sadly, while it was waiting, John is pretty impatient, and so is Ringo. They decided to skate again, so it was waiting. So this kind of cycles of skaters going in and out repeated, and then finally the cleaner got a chance to resurface the ring, right? It's done in exclusivity. So notice that while the cleaner was resurfacing the ring, neither Ringo nor John could skate because they had to wait for the resurfacing to finish, right? And then after the cleaner was done, then those two guys that were waiting, Ringo and John, then were able to skate, and the cycle repeated. There is another key feature of Reentrant locks called multiple conditions or wait queues off of a single lock that I didn't cover in this video because I did not want it to be too long. If you found this video useful, then please give it a thumbs up, subscribe, and hit the notification bell because I publish videos here on a regular basis. I'm Nilton from craftofprogramming.com. Thanks for watching.